Welcome to another work solution. Today we're going to be looking at question 6 from the Maths SL 2014 Time Zone 1 Paper 1. Now this particular question requires us to have a knowledge of definite integration and also radians and the unit circle. Right, so if you're looking to brush up on those, they're the areas that you want to look up in your textbook. That's the definite integration and specifically of trigonometric functions and radians and the unit circle. All right. So first of all, we've been told that the integral of cos 2x between pi and a is equal to a half. So let's integrate this or find the antiderivative of cos 2x. So a half will be equal to, let's find the antiderivative here, so cos 2x, that will be sine 2x over 2. All right. Now, if you'd like to know how I found the antiderivative of cos 2x dx, there'll be a link below to a video that will show you how to do that. And this is a definite integral, so it's between the points pi and a being the unknown that we're trying to solve here. So we need to turn this into, well, we've got the equation right here. So that definite integral, which is equal to a half, looks like this. So we've got sine 2a over 2 minus sine 2 pi over 2. All right. Now, because they're all being divided by 2, we can multiply both sides by 2, and that will get rid of our denominator there. So we'll just end up with 1 is equal to sine 2a minus sine 2 pi. So these are our angles. The sine of this angle here minus the sine of 2 pi is equal to 1. Now, you might recognise here we've got the sine of 2 pi. So 2 pi is the angle that we're talking about, and that's in radians. So if we have a look at a unit circle, all right, there's our unit circle here. Now 2 pi represents 360 degrees. All right, so if we go back, then 180 degrees will be represented by pi, and then 90 degrees will be represented by pi over 2. Now the sine of any angle is just the y-coordinate on the unit circle. So 1 unit away from the centre of the angle that we're talking about. So if we're talking about sine of 2 pi, so the sine of 2 pi, so this is 2 pi here, all right, the coordinate of that position there is 1, 0. So I can actually see the y component is actually equal to 0. So sine is the y component and the cosine is the x component. So we can see, due to our unit circle, that the sine of 2 pi is actually 0. So we know that 1 is equal to the sine of 2a minus 0. So therefore, we have sine 2a is equal to 1. Now, at what points, at what angles is the sine 1? So let's go back to our unit circle here. At what angles is the sine or the y-coordinate going to be 1? If I have a look here, I've got 0, 1. So I can actually see that at 90 degrees, or using radians, pi over 2 radians, the sine is actually 1. All right? And I can write that like this. I can see that the inverse of 1 is actually equal to pi over 2, which means that 2a is actually equal to pi over 2. So I'm not actually looking for 2a. I want to know what a is. That's what I'm looking for here. And that will simplify to a will be equal to pi over 4. Now let's go back to the question. And the question is asking us to find the value of a. And we've found a value of a being pi over 4. But it says here that a is actually between pi and 2 pi. So a is actually between pi and 2 pi. And we've found a value for a which is actually at pi over 4. So the corresponding angle is going to be pi plus pi over 4. Okay, so this is actually between our 2 points of pi and 2 pi. So to satisfy the question, a is actually equal to pi over 4 plus pi, which will be equal to 5 pi over 4. Okay, I hope that helped. Now go to that link below if you want to know how to find the antiderivative or the integral of the trigonometric function, the cosine 2x, cosine of 2x. And if you need any clarification, please comment below. And if you'd like any other work solutions to be done, also comment below and let me know. Thanks for watching.